Hello, I'm Kirk Weiler, and this is Common Core Algebra 2. Today we'll be doing Unit number 10, Lesson number 12, on solving fractional equations. So there's many different equation solving techniques that you're going to be coming out of this course being more and more comfortable with. One of those that we're going to work on today is how to solve equations that involve fractions. And I'd like to begin by hopefully reviewing a technique that you saw both in Algebra 1 and Geometry, and perhaps even in middle school. All right. One very common thing that occurs in mathematics is solving fractional equations where we simply have a fraction equal to another fraction. And in this case, the technique of cross multiplication works wonderfully. All right. In other words, taking this numerator and this denominator and multiplying them, and then taking this numerator and this denominator and multiplying. Now, many of you will do that multiplication in your head, and that's completely okay because it's pretty easy to actually multiply those two together and multiply those two together. But I do want to point out something before we finish this. Both techniques that we're going to look at today, because we're going to look at two of them, this one and another one, their sole purpose is to actually take an equation that involves fractions and rewrite it as an equivalent equation, or an equation that has equivalent solutions, that has no fractions in them. So notice, after we cross multiply, we have an equation with no fractions in it. It's pretty easy now to bring the 2x over here, bring the 25 over there. It's not the nicest answer, granted. But then we can obviously just divide both sides by 18, and we'll get x equals negative 27/18. Then we can simplify that to negative 3/2, or negative 1.5. It's all good. All right, now that was a very simple example of a cross multiplication problem. All right, where I get worried with students is in a problem like this. Because you'll get students who will say x plus 1 times x minus 6 is 2x minus 5, or they'll do the x's times x's and the 1 times negative 6. Look, don't cheat yourself out. Right? Write that down first. Then write this down. Then deal with it from there. Okay? Once I've done that, the fact that there's a fraction in it is somewhat irrelevant. Now, or the fact that there was a fraction in it, now I have to just do my usual mechanics. I got to multiply all this out using some foiling technique, multiply this out. And at this point, because I have an x squared term, I'll probably use the zero product law. Well, actually, I'll definitely use the zero product law. I'll subtract a 4 from both sides and add a 2x. And I'll get x squared minus 3x minus 10 equals 0. Do a little factoring. Minus 5 plus 2. X equals 5. X equals negative 2. There we go. Right? Not too bad. Pretty standard. Every single algebraic step along the way in that problem you know how to do. The question is, will you string them all together at the right time? Will you know that you should FOIL out that binomial times that binomial? Will you remember to use the zero product law when you see an x squared? And hey, you could also use the quadratic formula. That's great too. Pause the video now and write down anything you need to before we move on to the newer technique. Okay, let's move on. Now, in those last few problems, we had a fraction equal to a fraction. Now we're going to move into scenarios where there's more, the equation's more complicated. Specifically, we have 3 or more fractions. So let's take a look at this first problem. 1/2 minus 9 divided by 4x equals 3 divided by 4x. Letter A asks a pretty easy question. It says, what is the least common denominator for all 3 fractions in this equation? In other words, look at the 2, the 4x, and the 4x. What is the least common denominator? If you were going to add these together, what denominator would they have? Think about that for a moment. They would have a denominator of 4x. Okay? Now, what we're going to do right now is we're going to use a technique that is So similar to the technique we use to simplify complex fractions. Do you remember complex fractions? Complex fractions that sometimes students actually get these two processes confused. What I'm going to do is I'm going to multiply both sides of this equation by the 4x, right? I can do that. It's called the multiplicative property of equality. I can multiply both sides of this equation by the same thing and the equality will still hold. Now on this side, I'm going to distribute that 4x and I'm going to take it nice and slow in this first problem. We may speed this up in subsequent problems. Because just like with complex fractions, what I'm looking for here is for all the denominators to go away. And they do. Watch. 2 divides into 4, which gives me 2, and then I just have 2x times 1, which is 2x. Here the x and the 4 and the 4 are going to cancel. That just leaves me with the negative 9. And likewise, everything's going to cancel there, leaving me with a positive 3. And notice what's so amazing about this. We took an equation that just looked horrible, had fractions all over the place in it, and we came up with one using a property of equality that has no fractions in it and is easily solved. Except for the fact that I can't seem to add 9 and 3. That was a little bit weird. Anyway, our final result is x equals 6. That's the whole technique. Believe it or not, that's what we're doing for the rest of this lesson. We're going to multiply both sides of the equation by the same thing. Have to do that, so that we cancel out all the denominators and we're left with an equation that does not involve fractions. It's pretty much that simple. Okay, pause the video now and think hard about letter B. Okay, I'm going to clear out the text. And let's take a look at a multiple choice problem. So, it's going to be a little tricky, a little dicey. All right, which of the following values of x solves the following equation? I'm going to rewrite it right here. Now, what I want to do is I want to look at those 3 denominators, the 6, the 10, and the 15. Now I can think about least common denominators and all of that, or I can just think about what number would cancel a 6, a 10, and a 15. And there's lots of good choices. 60 would do the job, but the smallest number that will cancel all of them is their least common denominator, and that's 30. All right, so I'm going to multiply both sides of this by 30. And again, I'm going to take my time here. Because I worry sometimes that if I go too fast, it might be confusing what I did. All right, well, let's see what happens. 6 goes into 30 5 times. And now I have to distribute that 5. I'm going to do this part together. 5x minus 20 plus, that's this one. 10 goes into 30 3 times. Then I'm going to distribute it. And I'm going to get 3x minus 6 equals 15 goes into 30 twice. 2 times 31 is 62. And now look at how nice this is. We have an equation that has no fractions in it. We started with one that had obnoxious denominators, and now we have one that doesn't. So we'll get 8x minus 26 equals 62. Add 26 to both sides, and we'll get 88. Divide by 8 on both sides, and we'll get x equals 11. All right, not so bad so far. We're going to get some on the next side of the sheet that are a little bit tricky. Pause the video now. Okay, let me clear out the text. And let's turn that sheet over. Oh, x squareds. Piece of cake. It's going to be no problem for you. All right, same idea, right? As I like to say, same song, second verse. We've got a 10, we've got an x, we've got a 5x, we've got an x squared. I need something that's going to cancel all of those out. Think about what that would be for a moment. All right, did you figure it out? It's 10x squared. Okay? So what I'm going to do is I'm going to use that, and I'm going to multiply the left-hand side by it, and I'm going to multiply the right-hand side by it. You just have to take your time. Don't rush these. Now again, I'm going to write this out. If you're able to do this without writing it out, good for you. That's awesome. I like to be super careful on these, apparently to the point where I run out of space. All right, let's see what we have. Well, in this first product, the 10's cancel, and I'm just left with that x squared. Minus, here an x cancels with an x, that's it. So I'm left with a 10x equals. In this, the 5 cancels with the 10, leaving me with a 2, and the x cancels with an x squared, leaving me with an x to the first. Minus, and in this case, x squareds cancel. 2 times 10 is 20, and we have that. And again, notice what we've got is this beautiful equation with no denominators, right? No fractions in it. Because it's got an x squared in it, I should be thinking zero product law or quadratic formula or completing the square. If I get everything over to one side and equal to 0, I have something like that. And I will get minus 2, minus 10, x equals 2, x equals 10. All right, that seemed pretty easy. Why don't you pause the video and try to tackle letter B? It's very, very similar. All right, let's go through letter B. Like letter A, it's pretty easy to identify the fact that we should multiply everything by 4x squared. Okay, so I'm going to do that immediately and distribute. So I'm going to multiply that 1/2 by 4x squared. I'm going to multiply that 3 over x by 4x squared. I'm going to probably run out of room. It looks like I am. Okay, well, not great. Sorry about that. That was the right-hand side down here. Let's do some canceling. See if we can make this a little bit smaller. All right, here 2 will cancel into a 4, leaving me with a 2. All right, write it down here, 2x squared. Here an x will cancel an x, but I still have an x there. But 3 times 4 is 12, and another x. All right, here the x squareds would cancel, and they just leave me with this negative 4 equals. Here I have an x canceling an x and a 4 canceling a 4. I gotta watch out because I'm still left with that x. And here the x squareds are going to cancel, and 2 is going to go into 4 twice. So that's plus 2, and there is a plus. That's kind of got lost. I had to look up at the original to figure out if it was plus or minus. Again, we've got an x squared term. Let's think zero product law. If I subtract an x from both sides, I'll have 11x. If I subtract a 2, I'll have negative 6. All right, at this point, I can factor. 2xx, remember my smart factoring tip, which is don't put another even in here, otherwise you'll have a GCF. So maybe put a 6 here and a 1 here. That'll give me 12. 1 is going to be 11 as long as that's positive and that's negative, and then I get a negative 6. Obviously then, the zero product law, I'd get x equals 1/2 from this factor, and x equals negative 6 from that factor. All right, that's not too bad. I mean, what's so bad about this? Equations that have fractions in them. Multiply both sides of the equation by something to eliminate all the fractions. All right. Now there is one little twist on this, and we'll get to it in a moment. But pause the video now and write down anything you need to. All right, clear this out. The last thing that we have to be concerned about in these problems is the possibility of extraneous roots. You remember these. They came up when we were solving square root equations, extraneous roots. And they're kind of obnoxious, but let's jump in and see how they arise. So look at this equation. Now, Probably, if nothing else in this unit, you are probably to a point that when you see something like this in a denominator, you probably think to yourself, I should probably factor that. In fact, it factors as x plus 3 times x plus 5. So I haven't really done anything yet in this problem other than rewrite that one denominator in its factored form. But now I need something that will cancel an x plus 5 and an x plus 3. That means I'm going to multiply both sides of this equation by x plus 5 times x plus 3. So let me show you how this all looks in its written out glory. I am literally doing this. Lots of writing in recent lessons. Right, multiply both sides of the equation by x plus 3, x plus 5. All right, remember this is going to have to distribute. Okay. Now, when it does, I'm going to try to skip writing out the next step. When I multiply this fraction by these two factors, the x plus 5s are going to cancel, but my x plus 3 is going to still be there, as is my x plus 1. That's going to be annoying. At least here when I distribute, all those are going to cancel. I'm just going to be left with 18. On this side, the x plus 3's will cancel, and I'll be left with 9 times x plus 5. Now, I've got a long ways to go in this problem. I really do, because I have to multiply this out, and that'll give me x squared plus 4x plus 3 plus 18 equals 9x plus 45. So that'll be x squared plus 7x. Whoop, there's no 7x there. That was weird. X squared plus 4x plus 21 equals 9x plus 45. Again, I'm thinking zero product law, I'm thinking quadratic formula, I'm thinking I need more space up here. Either way, if I get it all equal to 0, x squared minus 5x minus 24, I can now solve it. Quadratic formula is fine. Completing the square is fine, although much harder. And I'll get x equals 8 and x equals negative 3. All right, look at that. Now, one of these two values of x is actually extraneous. It would not make the equation check. And by the equation, I mean the original equation. Now, we're going to explore why this happens in the next lesson, or actually a couple lessons down the road. But just take a look. Which one of these is problematic? Think about this for a minute. Yeah, this one is out. Not because it's negative, but because if I substituted x equals negative 3 into this denominator, or into this denominator, it would force me to divide by 0. And there is no division by 0. Right? So that's out. Now the x plus x equals 8, no problem. I'm not going to even check it. The reason that the x minus 3 is extraneous is because it causes two different denominators to be equal to 0. If it even caused one denominator to be equal to 0, it'd be extraneous. But x equals 8 can't cause the denominators to be equal to 0, so it's perfectly fine. All right, pause the video now and then we'll do one last problem. All right, let me clear out the text and have you work on the last one on your own. Take a shot at this one and reject any roots that are extraneous. Okay, let's go through it. Well, just like before, I want to take that initial denominator and factor it. And it does factor as x plus 6 times x minus 2. Got some red going on there, stray marks all over the place. Sometimes my pen doesn't make any sense to me. X minus 1 divided by x plus 6 equals 1 divided by x minus 2. All right? Now, in this case, again, because I've got an x plus 6, x minus 2, x plus 6, x minus 2, what I want to do is I want to multiply both sides of this equation by x plus 6 and x minus 2. X plus 6 and x minus 2. All right, this one's got to distribute. This one doesn't. One thing that's nice is immediately when I multiply this quantity by this one, that denominator cancels, and I'm just left with 4. On the other hand, here, the x plus 6's would cancel, but I'd be left with x minus 1 times x minus 2. Over here, the x minus 2's cancel, but that's not so bad because then I'm left with 1 times x plus 6, and I can handle that. So let's keep working it. Right here, we'll have to FOIL it out. What will that be? X squared minus x minus 2x is minus 3x, negative 1, negative 2, positive 2, equals x plus 6. So x squared minus 3x plus 6, right? 2 and 4 is 6, equals x plus 6. Whew, a lot of writing again. Oh, that's weird. I get x squared minus 4x equals 0, right? These two just canceled. I'm going to still use the zero product law. I can factor an x out. X times x minus 4 is 0. That's great. That means x is 0 or x is 4. Now, we have to determine, is either one of those an extraneous root? Well, would x equals 0 make that denominator 0? The answer is no. It would make it negative 2. Would it make this denominator 0? No, it would make it positive 6. Would it make this denominator equal to 0? No, it would be, I guess in that case, negative 12. So that one's good. How about 4? Well, no. The only way 4 would be rejected is if we had an x minus 4 in the denominator. But we don't. So both 0 and 4 are perfectly good roots. You do have to watch out for extraneous roots, but all you have to ask yourself is, do any of the values of x that I found make any of the denominators equal to 0? If they do, get them out of there. They're not legitimate answers. But if they don't, then you're all set. All right, pause the video now and write down anything you need to. Okay, I'm going to clear out the text, and then let's wrap it up. So in today's lesson, we reviewed the process of cross-multiplying, and that's something you should have in your tool bag. That should be, hey, I see a fraction equal to a fraction, I'll cross-multiply. But we also learned a really cool technique, which is to multiply both sides of the equation by something that will cancel all the denominators. Once you do that, you'll result in an equation that is much easier to solve because it doesn't have fractions in it anymore. The final thing, though, that we saw, a nice little wrinkle, was the fact that when you do that process, sometimes, not always, but sometimes, you will get extraneous roots. So you need to check on those. All right. Well, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.